Hello everyone, welcome to my channel. Now in this video we are going to have a look on the topic of electrostatic potential and electrostatic potential energy. Now very often it is seen that students have doubt with regard to sign of energy and sign of potential. So I will try to clear all those doubts in this video. Now this video is entirely based on your NCERT. Okay. Now say suppose you have a charge Q, okay, and this is a point charge, and at this point, which is at a distance r, suppose we have to calculate the electrostatic potential energy or electrostatic potential. Now let us mark this point as say O and this as A. So this distance OA is r. Now this is somewhere infinity, okay. So this is infinity, and from infinity we are bringing one charge, okay. Now suppose now the charge has reached this particular point, so we are bringing charge Q naught from infinity. Now in your NCERT it is given as +1 coulomb. This instead of Q naught they have given it as +1 coulomb. I am just taking it as Q naught. Now you may have a doubt, like in the chapter electrostatics we are studying charges at rest. So basically electric potential, electrostatic potential energy, these things are under electrostatics. So why is that we are studying about the charges in motion? Like in this case, see, this charge Q naught is practically at rest. It is brought from infinity towards this charge Q very slowly, okay. It is brought in such a way that net force on this charge is 0 at each and every instant, okay. So it is brought very slowly. Now this is Q naught, now it is at this particular point, and suppose this distance is some r prime, okay, and now it is brought in this direction through a distance dr prime, okay. Now when it is at distance r prime, the force on this Q naught, when it is at this particular point, the force on charge Q naught, force on Q naught will be 1 by 4 pi epsilon naught Q naught by r prime square, okay. This is the force, okay, and this force is acting in this direction, in the radially outward direction, and since we are bringing the charge towards A, towards this charge Q, so we must apply a force which is equal in magnitude to this force, but in the opposite direction, slightly greater than this, but in the limiting case we can assume that the applied force is almost equal to this force. So in order to move this Q naught through a distance dr prime, the work done will be dw is equal to 1 by 4 pi epsilon naught q naught by r prime square dr prime. This is the work done, but this with a negative sign, okay. Dr prime in this case it is negative. Why dr prime is negative? Because see, r prime we are measuring in radially outward direction, okay. So that means dr prime is also in the outward direction, and we are moving the charge against the direction of dr prime. So for that we have a minus sign over here, okay. So this is the work done in moving charge through this distance dr prime, okay. So total amount of work done in bringing this charge Q naught from infinity to this location will be W is equal to integral infinity to r dw, okay. That is, we have to integrate this from infinity to r, this particular location. So we have W is equal to Q naught by 4 pi epsilon naught infinity to r dr prime minus dr prime by r prime square, okay. So now let us integrate this. So this is W is equal to, now let me take this minus sign outside, so minus Q naught by 4 pi epsilon naught 1 by r prime square. So this is equal to minus 1 by r prime. Limit is infinity to r. Okay. So this on integration we get, so this gets reduced to w is equal to minus q naught by 4 pi epsilon naught. Substituting the limit, we have minus 1 by r, and then this 1 by infinity is 0. So this is plus 1 by infinity. So this quantity is 0, this minus minus becomes plus. So we have w equal to 1 by 4 pi epsilon naught q naught by r. Okay. So this is the expression for work done. That is the work done in bringing this charge q naught from infinity to location A. Okay. So now this work done gets stored in the system as electrostatic potential energy. So this is also the expression for electrostatic potential energy U. Okay. And how do you define electric potential or electrostatic potential? Electrostatic potential is defined as work done per unit charge. So V is equal to work done per unit charge, that is work done divided by q naught. Now, so this quantity divided by q naught, so q naught gets cancelled. So we have V is equal to 1 by 4 pi epsilon naught q by r. So this is the expression for electric potential due to a point charge. Okay. Now, what is the significance of this expression? Point charge q at distance r at this point, suppose the electric potential is V is equal to 1 by 4 pi epsilon naught q by r. Okay. So that means if you move away from a positive charge, the electric potential will decrease, and if you move towards a positive charge, the electric potential will increase. Now, whereas for a negative charge, suppose this is minus q, this is r, at this particular location V will be 1 by 4 pi epsilon naught minus q by r. Okay. For negative charge, the potential will be negative. So in this case, as you move away from a negative charge, the electric potential will increase, whereas if you move towards a negative charge, the electric potential will decrease. Okay. So that is the significance of this minus sign. Okay. So this is how electric potential varies for a positive charge as well as for a negative charge. Okay. Now the other important thing is, like for a point charge, see, this is how the electric potential varies. Okay. Whereas for at this distance, the electric field will be 1 by 4 pi epsilon naught q by r square. So the fall in electric field intensity, it is E is inversely proportional to r square. Here V is inversely proportional to r. So fall in electric field intensity in comparison to electric potential will be much faster. Okay. So that is explained in this graph, as you can see, page number 55 in your NCERT textbook. That is, the fall in electric field intensity is much faster in comparison to electric potential. Okay. So the graph is, suppose this is R, and this side you have E or V. So if this is potential, electric potential, this is electric field, this is E, and this is